Hello, good afternoon to the doctor and my fellow friends. Today we will learn about the wall insulation material by Group 1. So for the introduction, building envelopes, especially walls, play an important role of controlling heat transfer into a building. In Malaysia's hot climate, a large amount of heat enters through the wall, increasing indoor temperature and the use of air conditioning. By using suitable insulation materials and wall configuration, heat transfer can be reduced, improving indoor comfort and reducing energy consumption. Therefore, this project evaluates the thermal performance of different wall systems to identify the most effective design. There are four objectives in this study. The first one is to analyze heat transfer through wall system using thermal resistance concept. The second one is to compare the thermal performance of conventional and insulated wall. The third one is to determine the effect of insulation on reducing heat gain. And the last one is to evaluate sustainable aspect of insulation material in building application.
So now we go to the system descriptions where we assume the value that needed to do the calculations. So the first table is about dimensions of the wall. We assume the inner concrete block, rock wool, insulations, air cavity, and outer clay brick. And the next table is about materials and physical properties. We assume the thermal conductivity, density, and specific heats for the concrete block, rock wool, and clay brick. So this is for the environmental boundary conditions. All of these value were used in the calculations.
So, as for the analysis heat transfer, first we assume it is in steady state condition, which is heat transfer is assumed to be steady state, and we can say that dt over dt equal to 0. Second is our assumption one dimensional heat transfer, which is heat flows strictly perpendicular to the wall surface. And thirdly is constant properties. Material thermal conductivities K and convection coefficient H remain constant across the temperature range. So basically, this is we differentiate into three configuration, and we can see here the case one is our the case one including brick, air gap, and concrete. There's only air gap for the insulation of the heat transfer between brick and concrete, and we can see here the heat released is quite higher, which we can say here is 101.76 watt. So as for the configuration 2, case 2, including brick, rock wool as the interior insulation material and concrete for the outer wall. So as for the rock wool as the insulation material, we can see that the rate of heat transfer is lower, which is you can see here the heat flux is 1.888 watt per meter square. So this is case 3, which including brick as the inner wall, air gap, rock wool air gap as for the insulation material, and concrete as the outer wall. So here for the insulation material, we have rock wool and also air cavity gap to slowing down the heat transfer rate even better. So we can see that here the heat transfer rate is slower than case 1 and case 2, which is 26.6 watt. So indeed, rock wool and with additional air cavity in between the rock wool is the best to slower the rate of heat transfer.
This table compares the thermal performance of the three wall configuration. Case 1 has the lowest thermal resistance, 2.356, because it only uses an air gap as insulation. Therefore, it has the highest heat transfer rate of 101.76 watt. In case 2, the air gap is replaced with rock wool insulation, which has a much lower thermal conductivity. This increased the thermal resistance to 5.298 and reduced the heat transfer to 45.31 watt. Case 3 gives the best performance because it combines two air gap with a rock wool layer. This provides the highest thermal resistance of 9.019, resulting in the lowest heat transfer rate of 26.60 watt. Overall, higher thermal resistance means less heat can pass through the wall, making case 3 the most energy efficient design.
So lastly is conclusion. This project studied heat transfer through three-wall system. The results show that using rock wool insulation reduced heat transfer and improved the wall's thermal performance. Case 3 gave the best result because it had the highest thermal resistance and the lowest heat transfer rate. In conclusion, rock wool insulation is a good choice for improving energy efficiency, reducing cooling costs, and making building more comfortable and sustainable. Thank you.